criteria, so you move it upwards to the maximum possible, consistent with those criteria. Then you take the reading at 500 hertz, and that's the STC rating. So they have found out that this is a good way to find a rule of thumb of the sound transmission loss across materials, and that will give you the sound transmission class of that material. Therefore, sound transmission class is not calculated, although you make calculations to find the end result. However, without taking measurements and plotting those measurements here, you cannot find an STC. It's all by test. There are software that mimic the STC rating and can give you an expectation of the STC rating based on the mass law, but those are not real STC, because real STC is based on testing, all right, tests and measurements. So when you see an STC of any material, that means that material have been tested in the lab, and that STC has been found according to those tests. There are things called ASTC and FSTC, which is field testing, and the value of that will be different by 5 decibel from the value of the STC rating taken from the lab measurement. Anyone understands what I'm saying?
So we have to add 5 numbers to the theoretical STC?
You have to improve it by 5. So if your reading is a reduction of 40, the FSTC, that means the STC will be 45. Yes, so reduction of 45 decibel, or you add, as you said, add 5 decibels more to the reduction. All right? Okay.
So when we are designing, our STC required is 40 means you will design it for 45.
It's not like that.
35.
It's not like that. The reason why in the field test there is always a greater sound transmission is because of flanking noise.
What is flanking?
Flanking means you have a partition, but there is noise that's gonna go up, noise is gonna go down, noise is gonna go around. That is called flanking noise, and that is in general compensated by adding this 5 decibels. That's it.
I think you people need to understand this.
Very, very important terms, NRC, STC.
STC for you is more important, especially for this material. NRC is going to be material important for the other material, which is the panels, once you start selling that. So this is an example of how a curve is plotted, and it shows you, you take the reading at 500, so you go from 500, you take the reading from the STC curve, and that's going to be STC 25. You don't take the reading from the test curve, not from here, it's from here, okay, at 500 hertz, but from the STC curve, and that's going to give you the STC rating. All right?
How many of you want STC basics to be revised once again? Sound transmission class. Because this is going to be the basis for our business.
Yes.
STC. First, whatever
Before,
we have is the basics. Now we are coming to the core subject of us.
Now, before I revise this concept, I just want to tell you something. No one talks about all this in real life. They just talk about STC.
Yes. What is the STC that you are?
Just one number on the specific. You have a catalog of the FF underlayments?
Our catalog. RMS Max catalog.
Anyone has a catalog or piece of catalog? Anyway, I have snapshots later. We can see it. No problem. It's okay. I have snapshots. So I'm going to repeat a little bit. The sound transmission class. The sound transmission class is related to sound transmission loss. and that's a one number measurement for material to tell you how many decibels that material is gonna reduce the noise when that noise is going to pass through it. Always remember that there is flanking noise, and that is also something you must remember when you talk to consultants. So if they tell you in real life there is a difference between what you're doing and what we have in real life, you tell them this STC is under strict lab conditions. That's the number, STC here. Yes. So here you can see STC 59. And the STC 59, is it for this material? With the one we see here. Is it for this material? Yes? No. 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 It is for this assembly. The whole system. And the whole system, including the material itself, is tested in the lab. The whole system. Once you test it in the lab, you get an STC for the whole system, not for this.
It is similar to FS1 doesn't have a fire rating. FS1 with the system, wall has got a fire rating.
Absolutely.
Exactly the similar method is.
Absolutely.
SPC is not against
So
the material.
if someone tells you my installation is not giving STC as you said, you tell them first this should be exactly the same assembly. If it's not the same assembly, you cannot claim the same STC. Second, when you test it on site, using, of course, standards, like you need to go to the ASTM exact standard methodology for testing to get it. You can do that on site. However, there is flanking noise. Flanking noise gonna affect the STC rating of that system. Noise coming through the wall and through the parapet, noise coming through anywhere. Tubes, pipes, I don't know. So there is flanking noise that's gonna come. So you cannot claim exactly the STC rating because that's under strict lab conditions.
The variance will be 5 decibel, right, sir?
Normally, as a rule of thumb, yes. So when you test it on site, you find out it's 40 decibel, you can claim 45. Okay?
So that means that if I have a barrier here,
Yeah.
sound is here 100 decibels, the other side, if I say 40 decibels, the other side only 60 decibels will be audible. Is that correct?
Yes and no. You can claim that when you're talking to layman, because you can say that I have 100 decibel and my wall is 40 decibel, on the other side is going to be 60 decibel, right? Yeah. However, remember that sound is made up of different various frequencies. So what is the amplitude envelope of that spectrum? Where the intensity is higher, at low frequencies or at high frequencies? That makes a lot of difference. A lot of difference. So
How do we get to know that?
you can't. So don't get into that. Just claim the obvious. So you have 100 decibels. Other side's gonna give you 60 decibel if the partition is 40 decibel. That's it. And for the consultant or the contractor or the owner, what they don't know, it doesn't hurt them. You don't need to explain all this. If you explain all this, you know what we'll do? You will put yourself in a trap. The consultant will tell you, no, I need you to analyze all the frequencies of the noise coming from there, and you have to give me the exact sound attenuation on the other side, which is it's gonna be a mess for you. Don't do that. Yeah.
So what is the meaning of our underlay with a slab when we give a system?
We're going to talk exactly about the underlays. I have those catalogs on the slides. So coming back to STC, this is how it is rated. So you have three bands. So from 125 hertz to 400 hertz, there is a 9 dB change per octave. Then from 400 to 1.25, you have 3 dB change per octave, and then above that there is no change. That is the curve used for the STC. You take some measurements. The measurements should be should satisfy these two conditions. So no single transmission loss may fall below the curve by more than 8 decibel, and all the deficiencies below the curve should not add up to more than 32 decibels. So when you overlay your curve like that, these two conditions should be satisfied. If you take here, you add up here 1, 2, 3, 4, 5, 6, you add them, they're going to be not more than 32 decibels. And if you look at any one deficiency, it's not going to be more than 8 decibel by itself. So what is the biggest one? I think this one. This one. That's exactly 8 decibel. Yes? Right? Right. That's it. So no more than 8 decibel deficiency. And when you add them all together, they're not going to add up to more than 32 decibel. Once you overlay the curve like that, you take the reading from the 500 hertz to the STC curve, not to the noise curve, and you take the reading. That's the STC rating of that material.
When we add up, when these curves are overlapping each other, it's negative and positive, or everything is in positive?
The deficiencies, that means here.
Only the deficiencies.
Yes. All right. So this is how it is tested in real life. In fact, in the lab, this is how they test it. So you have 2 rooms, and you have the test material here in the middle, and they emit some incident sound from here, and they have a microphone here. So this is the source room, and this is the receiver room, and they are totally isolated. You can see that there is a gap here, so no transmission is by vibration. And then there are thick panels and so on. And then the test is going to give you the noise frequency for each, at each third octave. You put them on the curve and you get the STC rating. All right?
Till now we have not studied about resonance anywhere. If some vibrating material is there inside a room or anywhere.
Yes, you're not going to study about that, but I'm going to give you a notion about what it means later on, a little bit later on. So that's a real measurement done in the lab. It shows you the STC rating, and it will give you from here the 500, it is 35. Sometimes you will see this notation. This is the European notation, RW, which is the same as STC. Okay? So that is important, because in some consultant specification it's RW coming from Europe, and in America it's STC. Okay? Well, it's the same thing. Moving on. The engineering prediction method for STC, as I said, you can predict STC by doing some calculation. It is based on something called the mass law, and it is related to the mass. So you have a certain material with a certain mass, so the density of that material will play a big role in saying how much transmission loss is going to go across that, or be across that material when subjected to a diffuse field of sound. Different material will exhibit different reductions under the mass law, and you can see in this graph you have assemblies here. For example, here we have cinder block and plaster and concrete, another type of concrete assemblies, a lot of things. So you have doors, you have these plywood with alternating studs. As I told you, they don't touch each other. So there's a lot of things here, and it will give you different rating for the sound reduction according to the mass per or density in kilogram per meter square. So density of a surface.
Density is kg per meter cube.
Yes, but that is density of a surface. because we're talking about a partition. So how much you have mass per unit of surface? You got me?
But if the thickness
It works. The more thickness, you will have the higher density per meter square.
so it is better to define in kg per meter.
No, we're talking about a partition. So how many square meters you have of this partition, and what is the density? It doesn't matter how thick it is. What is the density of material per unit of area of that surface? That is what is important. You don't agree?
Yeah, but if you increase the thickness,
That's it. Look here. Absolutely. So this one, obviously this one is the thickest one. Look, it's gonna give you 55, almost 60. This one is very thin. It's giving you 25. So the more thick it is, the better, obviously. And by doing all these tests, they notice they all fall on this range. That means the sound transmission loss is directly related to the mass. The higher the mass, the more loss you have. And that is the mass law.
Higher the mass, higher the loss.
Higher the loss. That's it. This is why when you have a block wall, masonry block, concrete, between two spaces, and you want to have that block wall in acoustic partition, you must have it grout filled, or you must have it solid block. Okay?
So when density of material increases, STC will automatically have an impact.
Automatically. It is related through the mass law. In fact, when I want to estimate the STC rating of any assembly, and believe me, the assembly is given by architects, they will make you very old in very little time. So they are stressful. So many layers you have inside, and then in the middle, and then air gap, and then outside, and then you have another material, and then the cladding. So 5-6 layers. How do you know the STC rating? Unless you take that material and put it in a lab, you're not gonna know the STC rating. But using the mass law, you can predict it. Okay? And the prediction, when I do a prediction, I base my prediction in conservative values. So I always try to reduce. So if the calculation gave me 57, I tell them this is 54, to be on the safe side. Okay?
so we can keep this as a thumb rule.
More or less, it is a thumb rule, yes. Even you can refer if you want, like there is the Canadian STC catalog. It is available online. It's a huge PDF file. You will find many assemblies for walls and for roofs, slabs, and the STC rating for each one of them. So that is the mass law for a single panel, because when you have different panels, that's gonna create some difference. So R is equal to 20 log of MF minus 47. M is the surface mass in kilograms per meter square, and F is the frequency in hertz. So it relates to the mass and to the frequency. Two things to consider. And when we're doing, it's giving sound here. I don't know, you still have? It's okay. When you're trying to predict, you need to make the prediction at each third octave frequency and then average, the same way we do for STC. Or you take that prediction and put the curve on the STC curve and see what would be the STC rating. Normally I do both. I do a weighted average and I do the STC rating, and normally the STC rating is more conservative. So I get about 3 to 4 decibels lower when I do the prediction using the STC rating as when I do the weighted average. But this is mostly when I have concrete in the walls. When we change material, things change. that prediction and those numbers are only for a single panel. So when you have multiple layers and air gaps, throw this equation out of the window. It's a different thing. Okay. So if we look at a single panel, once we increase the thickness of the same material, the mass per kilogram in kilogram per meter square, so per unit area, is going to increase. So by doubling the surface, the density is going to double, and so the reduction is going to be doubled. And that doubling is is not going to be doubled, it's going to be reduced by 6 decibels, so increased by 6 decibels. So between here and here, you see there is a doubling of mass, there is an increase of 6 decibel in performance. When you double again, there is another increase of 6 decibels in performance. And when you double again, up to 600 mm, so 60 centimeter thick, really thick one, there is again an increase of 6 decibels. So that can reach an STC or RW of 66. All right?
So it's not linear, that's why we are...
No, it's not linear. I told you a lot of things in acoustic are not linear, and so it is important to realize it is not linear when we're talking acoustics.
It is something similar to solar engineering. When we study, a lot of scientific facts will be having exponential numbers and all these things.
Solar
engineering is also...
Solar panels, you mean?
Solar panels, design of solar panels,
Yes.
and
Yes.
you have a lot of mathematics mixed with your engineering,
Yes.
and then the result will come.
There is a simple fact about solar engineering. When you buy a PV panel, they tell you it's rated for 400 watts. But then you're going to ask yourself a question. That it depends on the sun.
Yes.
And is the sun coming straight to that panel, or is it like this, or is it like this? In the morning, the sun is going to raise here, and then it's going to turn like this. And in the summer, it's going to raise here and it's going to be here. So the angle is quite different every single minute of a day and every day of the year. Number one. Number two, do you have clouds or not?
Correct.
Right?
And what height you are keeping? What about that?
Number three, do you have dust in Qatar?
Full
Like
of
in
dust.
UAE?
lot of this.
So I'll tell you, for example, this, I think it's joke in Masdar city in Abu Dhabi. They have this power plant. It's called Shams. Big power plant on solar panels. Now, and they claim like they are energy friendly and environmental friendly. So those power plants, they accumulate dust, a lot of dust. How do they clean them? They bring some water and they sprinkle with water. How is that energy and
Whatever energy you are
environmental friendly?
saving,
It's a kind of a joke. So for me, PV panels, I have a lot of doubt in if it works well here in the Gulf. Anyway, so if we look also at the frequency, there is also a relationship between the increase of frequency and the increase of the loss reduction, or the increase of loss. So there is 6 decibel reduction when you're doubling the frequency. Whenever you double the frequency, there is again a 6 decibel reduction. That is in general. All right? So the mass law, and here you have an example of heavy vinyl fabric, which is 5 kilogram per meter square, constant. When you're doubling the frequency, more or less, except for this one, it's going to be linear, and it will follow this law more closely. These two things, so this one and this one, will tell us that we can use that law to a certain extent, more or less confidently, when we're talking about a single panel, and we know the mass of that single panel. All right? So you can find, as a rule of thumb, how much that panel is going to reduce the noise across it. Okay? As salesman, you don't have to do that whatsoever. Whatever is not written in front of you, don't use it. Use what is written. And you're only responsible for what is written in your catalog. You have an STC rating in your catalog, you only claim that. Don't claim anything else. If anyone tries to come and tell you, you need to find me that and this, tell them, this is useless. Try to get away from there. Don't get cornered in that trap. Don't let them ask you for things that you don't have and you cannot provide easily. What you can provide, what you can claim, this is what you need to focus on, what you need to make it important. Let your client feel the importance of that number that is already there. Don't let them think about something else. Okay? Even if they claim knowledge, even if they claim science, you have to tell them that in real life, this number is the important one. Nothing else is of importance. I'm giving you the bottom line. Yeah. These are examples of real life STC blocks. So 8-inch, so 20 centimeter thick, concrete, solid concrete panel at 95 pound per square foot density will give you an STC of 58, which is quite high for a massive concrete wall. If you look at a grout-filled masonry unit, so without a grout, that number is 45. If you put grout and rebar, and then it's gonna be 48. And here, rebar and 2 coat of flat oil base paint each side, then it's gonna be 55. So when you start to change the material property and add more layers, that's gonna be more different. So whenever someone tells you about anything about the STC rating on the section shown on your catalog, tell them this STC is for this section. The more layers you add, that's gonna improve. If you're gonna reduce from there, that's gonna decrease, and I cannot tell you how much it's gonna decrease. But that is the minimum I can claim for that assembly because it's shown here. That's it. If someone really wants to get more information, then you need to do an STC testing on the lab. You have to take it to your local lab, or if you don't have a local one, you have to do lab elsewhere, and it should be recognized by your client at least, or your authority having jurisdiction that you can claim that test in the lab. Anyway, try to get away from there. Sell on the catalog. These are again different materials. So you have laminated glass. Do you know what's laminated glass? Laminated glass, that means pieces of glass laminated together, stuck together.
Sandwich panel.
Sandwich panel without an air gap in the middle. So you have here 39. This one is 5 mm laminated, and then air gap, and then 9 mm laminated. That's gonna give you 40. Here 5 mm, then 64 mm air, and then 6 mm. That's gonna give you 43. So you see, for example, in this one we increase the air gap, and that's gonna give us better performance, even though we don't have laminated glass, which is more expensive than normal panel glass. So by just increasing the air gap, you're getting a better performance. For doors, again, hollow core door like that one, that's gonna give you 20 and 21. Not that good. Here we have French door with single strength glass, sealed into frame, mounted in frame with brass weather strip. So that's gonna give you 31 and 26. So the more the door is massive and well sealed, the better the construction. So that door, in order to become a better acoustic door, need to be changed to a solid core door. That's a hollow core. So if you can know very easily if it's a hollow core or solid core. It's like a drum. It's empty inside. Even the wall, it's empty. So that tells you that if anyone is hammering out anything outside, we're gonna hear it very well here. It's not gonna stop the sound whatsoever. So in order to improve that wall and this door, you need to improve the mass. That means you need to add some layer, make it solid block, for example, and the door you need to make it solid door and make a good acoustic gasket all around. There is some kind of rubber gasket here on 3 sides, not down, which is not enough, not the least. They don't. It's not. It will not give you any performance. All right. These now we start something related to your actual material. So we have now metal decks and ceiling systems. The first one, 5-inch thick, is gonna give you 50 STC. This one with a ceiling of mineral tile fiber, that's gonna go up to 60. And then if you get gypsum board and resilient channel, that's gonna give you 55 STC 55. Now anything that is above 45, it means that starts to be okay. But in some standards that the rating should not go below 50. But that depends on the space and on the expected noise on the other side. But as a rule of thumb, anything above 45 is considered good. Okay? Remember that the STC is a single number that represents sound transmission loss at various frequencies. So always you have this and those all. And normally we are just concerned with this, but you can also find out these from testing information, and if it is required by the consultant or the entity with whom you are dealing, you can provide that information. I guess it should be available. Now we move to something else. So now sound transmission class is important to isolate sound that's moving through the air. So we have here some sound and noise. We don't want it to go to the other part of the or the next space. We use STC normally, sound transmission class. The other part that we're concerned with, especially with this type of material, is the IIC. Looks like it started.
Yeah, started.
Yeah.
See, the best thing here is
I don't know if the sound is. It doesn't look like I have sound here.
no problem. Let us know.
From the projector sound is coming.
Yeah, no problem. Let us run the video and.
Gonna repeat that. Again. Now this door, if you notice, it is. You will see the video again. See, minus 45 dB. That means gonna reduce 45 dB, and you can see the music is totally muted. You cannot hear anything anymore.
Still music is going on in the room.
Yeah. Let's do the other video. Maybe it's gonna be more clear. Totally muted. No more sound.
Expression.
And the sound is very, very loud, you know.
Yes.
Very huge sound.
Okay, so let's get back. So impact insulation class, maybe we'll do this concept and then we go to lunch and then we can continue after lunch. So impact insulation class measures the mostly the tapping sound, the tapping noise on the floor. And like here we have carpet, that kind of material is gonna muff the tapping noise the most. That is best. Even if you have very good STC rated material, but the surface is not soft like that, then the impact is going still to go through. So the impact insulation class IIC is also a lab rating like the STC, and it represents the isolation provided by a floor system subjected to a controlled impulsive load, which is like this. They have a machine that mimics the sound of footsteps, and this is how they take it. They record it and they see what is the IIC. Since there is no standard footstep, the impulsive load standardized is in a randomized manner under lab conditions. So they use it in a lab condition, but they mimic the random stepping of people moving. And you can see, for example, this is 6-inch concrete. It's going to give you a STC, an IIC of 81 with the wood flooring board and glued to concrete. So 81 with no flooring cover that goes drastically down to 28. You can see the difference with just one layer of half-inch wood flooring glued on the floor. This one, which is very similar to your material, so you have concrete and then you have pressed fiber that's different, the isolators are different, and R11 bats insulation. So it's like something like a floating floor underlayment. It's gonna give you STC of IIC of 60. That means a reduction of impulse sound of 60. So that layer of soft material in the middle is gonna stop the sound of impulsive noise coming through that material from one side to the other. All right? Clear? You can experience that when you have, for example, a floor above you with a lot of people moving, or in the case you have a roof floor basketball, that's gonna cause something like that. So how do we standardize that? So for the minimum IIC are set to 50 in the UBC code, for example, and the tested is 45, so 50 allowed by UBC, and FIIC, so field tested, is 45. So always there is a difference of 5, same like STC. So football noise is quite pronounced and very audible below. So an IIC of 50 will not stop a football noise. We need much more. Minimum recommendation would be about 65. However, the code tells you that you can go down to 50. Some codes, like the UBC. The point at which football generated impact noise become inaudible is something like 75. This way you will stop 100% the noise, or will not be audible. If you look at requirements, so minimum code is 50, quality 55, minimum quality, medium quality 65, and very high quality is 75. So that is related to IIC. FIIC, as I said, is always 5 less because it's field testing. If you want, are we now at 1? Yes. Yeah? So we can go for lunch and come back. So this is what I was telling you about. So if you have a vibrating equipment, and here you see the supports are on the sides, and in the middle the slab is clear, then this is poor installation. That's not good. Once you put a beam in the middle, that's gonna be better. If you add an inertia pad, that's gonna be even better. And if you add a direct concrete column support, or not necessarily concrete, or vertical support under that beam, that would be the best installation for any equipment on the roof. And that would reduce the vibration transmission to the least. All right? Not counting the work of your underlayment. So your underlayment does some work, but always you must support the consultant who's doing the design, or contractor who's doing the installation, in giving them that advice that it should be like that. That would be the best way to go before thinking about the underlayment. All right? The same thing when we were talking about putting the bedrooms toward the highway, or putting them on the other side towards the garden. The best is to put them towards the garden first, and then we think about the wall insulation. Yeah? Same thing is here. So think where to locate, how to locate your equipment, and then we think about the underlayment and how to put it. So before moving on to talk about the materials and what all the numbers on the catalog mean, I want to give you the idea about other metrics. So the first metric we want to consider is the OITC, or outdoor to indoor transmission class. And more often than not, I have seen consultants and contractors and even acousticians make the mistake of mistaking OITC for STC. But there is a big difference. The difference is that first, it does provide a number for rating roof facade and facade elements that are subjected to noise, but that noise is for transportation, coming from transportation. And so the calculation that you do to get the OITC is quite different than the calculation you do to get the STC. The higher the number, the better the noise insulation, and that is also similar to the STC, calculated over a frequency from 880 to 4000. And here you can see that the range is a bit bigger. That is because transportation noise go into this range. So you have a range of frequency going as low as 80 hertz and can go up to 4000 hertz. In this range, this is the range that is of interest to us when we are calculating OITC. So again, when you're meeting a client and they tell you what is the OITC rating of your catalog, tell them it doesn't work because there's not going to be cars going there. This is the OITC is noise coming from transportation. If they tell you it's noise coming from outside, tell them no, it's not noise coming from outside. OITC is noise related to transportation. It means cars, trains, and so on, only, nothing else. So normally it is created to test exterior facade elements, so walls and windows. So when they say what is the OITC rating for an underlayment, tell them no, please. OITC is not for underlayment, it is for facade elements. This is the only reason I'm showing you this, because it's not related to your material. All right? Because of the large range of expected sound, OITC values are determined for lower frequencies as well as and are often lower than STC rating for the same construction assembly. So you can see that the OITC rating for the same assembly will be lower than STC rating. And many standards tell you that a minimum should be 53 OITC rated. For example, in classrooms, it should be 53 OITC. And considering that this is lower than STC, then the same assembly would have, for example, 55 or 56 STC rating. The reason it is lower is that because it works over a bigger range, and that range includes lower frequencies, and that is the important issue. The lower the frequency is, the more closely we're going near to the natural frequency of concrete when we're talking about concrete. So the natural frequency of concrete is the frequency at which concrete reverberate or resonate. And that frequency is important because at that frequency, that material is not going to perform at all. So it's like the material becomes transparent to sound when that sound is at that frequency, because it's going to resonate with air at the same frequency. So it's like the wave of sound passing through air will hit that material. Since it's resonating at the same frequency, it's going to resonate with the same way, and the sound is going to keep on going. It's going to be totally transparent. So when we go very low, that is a problem. And that is where materials will fail. And this is why if you look in your catalog, you will find that performance at low frequencies is always worse than performance at high frequencies for a lot of material. All right. So there are others. So NIC, FSTC, and ASTC, we have talked about them. What is NIC? NIC, or noise isolation class rating, are based on field test also, like ASTC or FSTC, where the product is installed, so highly dependent on field condition. So normally when tests are required on site, we get either NIC or ASTC / FSTC, because that's the same rating. So may not be achieved in other areas of the building or another project. So if you get an NIC rating in a certain That's it. So either flanking noise or installation errors. Okay? These are the other, some other metrics that are used. Another metric is CAC, or ceiling attenuation class. It is used in partitions, in ceilings, in partitions in office places. So if you have a partition inside an office space, but that partition does not reach the ceiling, the roof. It reaches the ceiling but does not reach the roof. In order to isolate sound, you need your ceiling to be insulative in some way. So it measures the performance of a ceiling system as a barrier to airborne sound transmitted through a common plenum. So that's a common plenum between adjacent closed spaces such as offices. So here we have a rated partition, and only reaches the ceiling, and there is a common plenum, so here there's totally air. If there is a sound coming from here, the CAC will measure how much noise is going to go up and then go down. That's it. It is related only to ceilings. Okay? Sometimes if you are selling this material, the panels, and they are used as ceiling insulation, not as absorption, then you need a CAC rating. In acoustic ceiling suppliers such as or manufacturers such as Armstrong, for example, you will find both NRC and CAC rating on some of their systems. So not only NRC is important, also CAC is important in a lot of places where you need ceiling in such similar cases. So sometimes it is more cost efficient to close it all the way up, and sometimes you cannot close it. What will prevent you from making the partition go all the way to the ceiling? MEP, absolutely. You have ducts, you have pipes, you have a lot of things passing. Sometimes you have, in between those two cubicles, you might have 20 ducts and pipes passing. There's no way to make a partition. Services, all sorts of services. Sprinklers, HVAC ducts, water supply, drainage, and so on. Electric cables, and so on. There's a lot of things passing. So sometimes you cannot, but you still need to isolate for sound. So what you use is a CAC rated ceiling. Remember, CAC is different than NRC. CAC is to isolate noise. NRC is to absorb sound for the same space. You have ceilings that are both CAC rated and NRC rated. And you have ones that are only NRC rated. So that depends what you want to achieve under which condition. And this is, again, your task as a salesperson, as a marketing person to know what to use when, and how to advise your client to use which element. So they will tell you, I want sound privacy, you need CAC rated. If you want speech clearness or intelligibility, you need NRC rated. All right? So a good CAC rating would be above 34, 35. If it is 25 and lower, that means it's not well performing. All right? And when you see these numbers, you can always assume that it will reduce the noise by 25 decibel on average. For STC, for IIC, for CAC, NIC, FSTC, ASTC, all of them, it's about reducing the noise. Okay? NRC is a different story, is a percentage of absorption. So you will see 0.7. That means it absorbs 70% of the sound. Okay? So we are concerned mostly about floating floor systems. That is the main subject of this training. So floating floor systems are resilient supported panels, resiliently supported panels located above the structural system, normally above the structural system. They can be used to attenuate vertical as well as lateral noise and vibration transmission. So not only noise and not only vertical noise, also lateral noise and also vibration. So if you have any vibration machinery, they will attenuate. They are usually heavier and resiliently hung ceilings and thus have the attendant advantage of mass. So when you talk about a floating floor, you're not talking about the underlayment, you're talking about the whole system. And a floating floor includes the underlayment and the layer above it, and in many cases also the ceiling underneath the slab, which is hung from the slab. So all that system is the floating floor system. It's a floating floor system. Not the underlayment itself is the floating floor system. No, that's the underlayment for the floating floor system. This is offset somewhat by the narrow air gap and low deflection inherent of the neoprene or pressed fiberglass isolators that normally are employed. So what happens is you have neoprene and fiberglass, and those, they tend to change performance over time if they are pressed. And that air gap here, why this is here, this air gap, if it is pressed more than it should and the air gap is squeezed, then the performance is gonna go. That is something you must take into consideration. Not only that, if you are putting that on a wet concrete and the wet concrete go inside and there is no more air gap anymore, that's gonna be compromised. So you need to follow the directions of the installers, and you can see here in the picture that this should be down. Grooves are down. Putting it like this, useless. Should be like that. Okay. Some of these materials can become overloaded and crush over time, further reducing their effectiveness. So it is very important to understand the pressure coming on these materials. And there is a rating for each of these materials. If you go beyond that rating, which is the amount of pressure you apply on them, then the performance is going to be compromised. So always the performance is related to how much pressure you apply to them. Okay? So any concrete which flows into the space between the floating floor and shorts out the resilient support also severely reduces the effectiveness. As I said, if the concrete going to in these air gaps is gonna cause a problem. A grid of regularly spaced individual mounts is much more effective than a continuous material, since the load on each isolator is much greater, which will reduce vibration transmission. That is a good thing. And normally, historically, they used to do that separately. Now you have this inherent into your material. Already you have it made into a grid, and you have supports and air gaps alternatively. So that material is engineered to satisfy this condition on its own. You don't have to do anything, you just have to roll it out as it is. Sorry?
Bonding? No need of bonding.
Sorry?
Actually, this material is compounded by oil content, right? The concrete, there is no bonding between oil content materials.
There is no bonding.
Yeah,
No bonding
with oil
required.
content.
Not required.
Not required.
No bonding.
Actually, if you bond it, it will reduce the floating property. It's called floating floor because it's not bonded. What are you afraid of? That someone's gonna lift your chiller, 20-ton chiller? No, not gonna happen. So this material is not used to anchor anything. It's just a horizontal support. It does not have any structural property when it comes to horizontal sliding or vertical lift. No property. It only works by gravity. You put something heavy above it, it works. Nothing heavy above it, nothing there.
So before putting this one, the concrete should be
Of course,
clearly
always.
finish and,
If you remember, I told you in a
label should
previous.
be clear, huh?
Yes, I told you here.
Clear and it should be
Uh,
dry.
They are above the structural system. So your structural system should already be there. Okay?
You have to seal it properly, you have to take it properly.
Yes.
So it should not leak.
So you have to follow exactly the installer, the manufacturer procedure for installation. Okay? When there is wet concrete and there is chance that this concrete is gonna go inside the grooves, that's a bad thing. Your surface should be completely flat, no irregularities, to the tolerance required by the manufacturer. Of course, there is always some tolerance. If that's within the tolerance, then it's okay. That's it.
That means it will not be installed on these tiles and all.
below the tiles.
Below the tiles.
You can.
We are going to use.
And there are some models just for tiles installation. We'll see the sections now.
That is underlay, not
is
floating floor.
Yeah, it's an underlayment. So always you have it below the final finishing level, whether it's an inertia pad or it's a tile.
Floating floor, we are not going to use any screed, anything.
Screed,
No,
yes.
We do screed it.
You will see the sections. They are in your catalog. I took these straight from your catalog and I put them in my slides.
Let the presentation further move on, you will understand. Otherwise, we'll make you understand.
Yeah. So where very high transmission loss values are required, such as in the construction of sound studios, floating floors in combination with resiliently supported ceilings can yield very good results. So you can have floating floor in addition to resiliently supported ceilings, and that will improve the result. So the ceiling, resilient ceiling, which is a massive ceiling, not like this, has some mass. If it is hung from the slab, it will improve the properties of the floating floor. And this is something that is used, for example, in sound studios where you need absolute silence, no vibration, no problems whatsoever. Okay. These are some examples of floating floor. This one is with resilient gypsum board, double or laminated, I think this one. And it's gonna give you FSTC of 54. This one with a 2-inch thick fiberglass and 4-inch thick concrete up and 6-inch thick concrete slab down, and you have R11. So this is the insulation R11 type. This is the American notation for insulation, thermal insulation, but it will give you also acoustic property, and you have here very good, so up to 72 STC.
The one surface of the this floating floor, it will be contact with the wet concrete, right, sir? The above surface.
Yes, he is right, he is right. So this floating floor, always what we will do, no, under the grooves will be open.
Yeah.
It will sit on the dry part. The top one, definitely you have to screed on top of it.
Yes.
On the top of that mat, you can see there will be a plastic insulation is there.
Yeah.
Not only that,
the wet will not
your,
wash or
yes,
will
but
not
your
go inside.
critical point is the edge. You're
Yes,
right.
you have
The
to-
edge is your critical point. So some concrete might flow here and pick this up and go underneath. So you must make sure that your installation,
All the joints should be.
Yeah,
Exactly.
You need to tape it properly.
tape it properly and not let the concrete flow over the edges.
His point is, on top of that, there is a plastic
Yes.
There is a tape.
coating is there.
Yes.
Yes.
So it will not allow the water wet to go.
Yes.
Go down.
Your question is right.
See, why we are saying
I think
floating?
he is also had the same doubt. am I right?
Yeah.
Okay, you got it? Why we are saying floating? It has to float, the floor has to float. So you need to remove all the gaps and make it float. That is the meaning of floating floor.
Yes. Remember that I told you that fiberglass, where did I write this? Fiberglass, so there is some deflection in, so some of these materials, which is fiberglass isolators, become overloaded and they will have a reduced effectiveness. So this material here that has fiberglass in the middle, it might be effective to a certain time, but over time that effectiveness is gonna go. So that's a strong point for you to argue with, because your material doesn't have this problem. All right? Here you can see with this system, the STC rating goes up to 94, which is absolutely wonderful. So such a system can be used, for example, in a recording studio where absolute silence is necessary. You don't need any noise coming from outside. All right? The floating floor is most effective if it is heavy and point mounted. So here we have point mounted. Of course, the heaviness doesn't come from the underlayment itself, it comes from the slab that comes above it, but the point mounting come from these. So this will give you the point mounting. If we want to talk about impact insulation class, these are some examples. So that's a concrete floor. The IIC is, I have shown you this, 81 with wood panels and 28 without anything. This one with a floating floor in the middle will give you an IIC of 60. This good one also will give you 70. And this will go up to 82. So depending on your assembly, you can go higher and higher. So depending on the specification of your project, the assembly can be changed. And even those can be suggested. You can just replace this with your material, and you can suggest that to your consultant or whoever. So these are supporting material you can use even in your marketing. All right. So let's have a look at the materials themselves. So this is the flat one, flat resilient. So this is RNS mat, RST, which is, I believe, this one. Yes? This one, which is this. Yeah. Right. So here, this is completely flat on both sides. So normally, it is made of 94% recycled rubber, and that is very important issue you can use in marketing as well. Like in GSAS, they want recycled material in their projects. So pointing out that it is made of 94% recycled rubber can be a big plus for you to market that material.
And it has been exempted from the, that 5% tax. Customs duty.
Because it is made of recycled material. So showing all this information to your client will help you to market that material as well. And here they tell you it shows you, even in the catalog it's written that it is used under hard surface floor finish and over concrete and wood construction. So you can use either a concrete structure or a wood structure, and the floor finish is hard, should be a hard finish, not a carpet like that. It is used when superior sound control is required in multifamily housing, high-rise and commercial building, and protect ceramic tiles, porcelain and stone from substrate cracks. So if you have a substrate risk of cracks, that underlayment is going to protect your finish. Your tiles, they're gonna be protected. Engineered for direct adherence floor coverings such as tiles, stone, wood and vinyl flooring covering. So you can, you have a section. So I think we have some sections here, or maybe not for this one. Anyway, so how does it reduce sound transmission? So this is made of rubber, and that rubber is going to absorb the vibration and absorb the noise, and so it's gonna reduce the vibration. This is a section showing how it is with vinyl planks and the RNS, and I think this FAS2 is the glue, right? The adhesive used to lock it in place. Yes, I'm not expert in that, but I think this is how it is. So you have the underlayment in the middle, you have the adhesive on the floor, you put the underlayment and another adhesive, and then your tile will go directly above that. And you can see here that on the side you have another part of the also provided by the manufacturer, and you can use it for the baseboard, which is this one. All right, that would be the edge on the edge of your room. That's another example. So you have here ceramic tiles, and you have the adhesive and the RNS matte RST, and this is all on concrete slab. That's another example. The other one, the FF, which has these points down,
Floating floor.
that's for the floating floor, and this one is much more performance for mechanical rooms, for sports fields and the such. So it will give you high pressure tolerance, so you can put heavy things above it, and the range can go up to 1450 psi, which is quite high. You know what's a psi?
Pascal.
It's not a Pascal. It's pound square inch. So pounds per square inch. So how many pounds you have per square inch? You can get the equivalence quite easily in Google. So you can put 1450 psi will give you in Newton per millimeter square, or whatever unit is used by your structural engineer. Again, you have recycled, so 92%. All this information are actually copy-paste from the catalog, so you can find it. So it results mold, bacteria, fungi, and water. Penetration for pipe ducts and electric conduits and drain are easily accommodated, so you can easily open it and make a penetration. Rolls out quickly and is easy to install without the need of adhesive. So remember, no adhesive, especially at the bottom part. Can be used directly under gypsum, lightweight or normal weight concrete with no plywood formwork required. So you just put it and pour the concrete above it, no problem. You don't need
What
it.
is the first point? Can you explain that?
Continuous underlayment system that limits surface area contact down to 4% at 2 psi. So the contact area with the surface down is limited. That is what makes it absorb the vibration. This is the contact area. That is the important thing. This is what makes it work. Without those, it doesn't work well. This is what makes it work. It limits.
On top of it, when the pressure is 2 psi,
Yes.
2 pounds per inch square, then you will have only 4%. If the pressure increases, then this percentage also increases.
Yes.
Contact.
Yes.
Between the floating floor and
So
the
the more crushing you have, the worse the performance. Always you have to
PSI
remember.
is very high, because inch square is only this much, and on that you have about 2 pounds. It's very high pressure.
So if you have a 2-ton machine, but it's spread over 12 square meters, you can calculate it's going to be about this much, maybe less. So for multiple applications, so you have equipment rooms, you have football fields and terraces. So here you can see the restaurant terrace. All these you can use the underlayment in those areas. And of course, when you have machine here, you're supposed to have space down underneath, and that is the issue. You don't want noise and vibration to pass down. Same thing here and same thing here. All right, that's the most important idea. If we look at performance, the performance of the load. So here, when we are increasing the load, so PSI, you see that performance stabilizes after a certain time at frequency. So depending on the frequency, that this is the natural frequency of the material, the frequency at which it will start to give vibration through. So when you increase the pressure, it stabilizes after some time. So here you have, depending on the type, you have 10, 15, 20, up to 25 hertz. That means very low frequency, which is a good thing, because normally noise is always above that level, above 80, something we're measuring 80 hertz and above. Here, you also have the deflection related to load. So how this material is gonna be crushed or deflected by increasing the load. So that's again is important thing to note because it will tell you how much load this material will take. Normally you don't discuss those graphs directly, technically with your consultant, but it's good to know it, to know they are there, and it's good to know that they can withstand a lot of pressure and still perform. That is the important thing. If we look at some assemblies, so again these are snapshots from the catalog itself. So look at this. This is, you have 10 millimeter concrete topping, and then the RNS mat FF25, and then 15 millimeter or 15 centimeter concrete topping, underlay structure. So this is the structure slab. The STC rating is 70, which is quite high. The IIC is 65, and the natural frequency is 16 hertz, which is very low. So performance is excellent. Still with very little material. If you compare this to what we had here, around here you see a lot of things to give you 60 or 81 or 70. Here you're getting the same thing with just the underlayment in between two concrete slabs, which should be a cheap installation. All right?
You put concrete thickness above that mat, again 100 mm.
Yes.
That means concrete slab's thickness is going to 250 mm.
It's gonna be 250, yes.
Actually, normal concrete slab is 150 mm.
More than 200.
No, let me tell you something. Let me tell you something. Normally, for example, if you have an equipment room or a machine, rooftop machine, you have this concrete 100 mm under the machine itself only, not on the whole roof. And that is the what is called the inertia pad that you put directly under your mechanical equipment. But that is not part of the structure. That concrete is just to isolate whatever is giving sound above. Whether it's an electric or electromechanical equipment or it's a football field, it's the same thing. Okay?
It will be covering the whole room or the particular area of the mechanical.
Particular area where you have, this is what we call the inertia pad. So the inertia pad work is to isolate vibration mostly. But if you want to make an absolute cut of the sound, then you need to do the whole roof.
When we apply 2 layers, those grooves have to be symmetrical, or else it has to be arranged in a pattern?
No, you just put them above each other. So this is 2 layers here. Okay?
And adding each layer, the STC difference is 2, sir, because the first where the
Yes, you can see here there is 2 dB difference, which in my opinion doesn't add up to much. Best to go for this. But this I think is better for vibration, not only for noise insulation. It will
Sir,
perform.
Normally floating floor we are going to use for vibration. Is it possible if we use for normal voice control floating floor?
Yes, this is it. It is STC.
So, floating floor, both we can, both ways. We
Yes.
Can, but underlay we cannot use for the vibration control.
What do you
Floating
mean?
floor we can use multiple for noise control and vibration control.
That's the same thing. You can use.
But underlay we cannot use for vibration.
Both the things. For
Yes.
vibration control,
No,
vibration
no,
also.
no, sir.
Vibration
Underlay only for sound.
Sound control, not for vibration.
This floating floor for sound and vibration because of this corrugated question, sir.
You're talking about this?
Yes.
No, this will not be. It cannot be used.
It
No.
cannot be used.
Normally, you put this under inside, like under tiles or under vinyl tiles or ceramic
But
tiles.
this we can use multiple, both.
Yes, this one. And
For rough.
normally, this is either outdoors for terraces or in mechanical rooms. So heavy duty
Because of
use.
that cost, this per square meter will be very underlay is little cheaper. Floating floor per square
But
meter.
it can
But
be
your
used in
point
both
is
ways.
correct here.
Can be used.
Your point is correct.
Yeah, your point is correct, of course.
See, it is generally used for the heavy equipments or the mechanical rooms. And let us say the underlay will be used in different, okay. There is a combination of underlay and footing floor also. You can put the first layer before screed underlay. In between, you can put floating floor. Okay. So there is an underlay, there is a floating floor. And if you want to have a better impact, you can also suggest one layer of underlay here, floating floor here, and floating underlay here. That is also possible.
Yes, sure.
So there are different combinations you propose always, and that is beneficial
Of course.
because it will give better data.
ऐसा बकरा ऐसा पैसा जो बकरा मिलेगा
So
you
you
wanted
need
to
to
6
propose,
layers,
yeah.
put 6 layers, what is
Yeah.
it?
No, sir, but we are restricted only. We are only telling to the client that floating floor will control only vibration for machine house.
No.
It will be sound and
Sound and
vibration.
vibration both.
Sound and vibration.
Because see, I tell you, we are proposing now in UAE, we are proposing underlay, floating floor, underlay.
It will be more costly, sir.
Ah.
Yes,
Particularly
but
contract
it is
model.
costly because why? They need a solution because the equipment chiller is very heavy. For chiller equipments and certain specific, I am not going to propose it on every project. It is going to be project specific.
Nobody will take your bed.
Okay, sir, here is one question. Our chiller is means not covering whole room, okay? It's just one part of the
One
room.
particular
Okay?
area, yeah.
So these things, floating floor will come just for the particular
Yes, particular
position
area.
itself, not for the whole
No,
room.
the entire floor, the underlay. It will.
Okay.
But if we compose for the 4 room, that will give us a benefit.
It is. Yes, of course. This is the point. So if you propose only under the machine, it's vibration.
Question. As he asked, if this is the room and the equipment is occupying only half of the room,
Only this is
then
the
only this room has to be covered or only that machine area to be covered.
Very
That
good
is what your question, I am right?
Very, very good
Yeah,
question.
yeah.
Okay, fine. Now, I need to understand the weight of the equipment.
Okay.
So, as rightly we've been discussing, where are the point loads?
That's it.
Okay? Where are the point loads? Are those point loads having any base or not? If no base, then give them a base with isolators. Okay? So, we need to identify the point loads, calculate the point loads, and based on that, we need to recommend. So,
I will
it
tell
can be
you.
the full area, it can be the only platform.
I will tell you one
So
thing.
if it is going to only for the platform, the sound reduction will be there?
I will tell you one thing. I will tell you.
Particular.
Yes.
Can I
So,
Yes,
for the entire area, you recommend underlay, and for the floor, you
Mr. Mahindra, if you let me, I will explain this point. It depends on the machine, number 1, on the location, number 2, and what is underneath, number 3, and on the structure itself. So all these things play a role. Now suppose you have a really noisy machine, and underneath you have an office space. If someone, consultant, come and tell you, I'm just gonna put a pad under that noisy machine, tell them that is not enough. Because that machine, in addition to vibration that travel through the structure, there is noise coming through the air, and that's gonna go down. If you do not close the whole area, that noise is gonna pass. There is no way from that. Either get a silent machine and then put a pad underneath for vibration, or if the machine is noisy and nothing to be done about it, then you need to insulate the whole area. So it depends on the machine. Is it vibrating only, or is it in addition to vibrating emitting noise, actual noise that you can hear? So all these things play a role.
No, normally consultants won't agree for only small area, they will agree only for full room. They
Yeah.
won't agree only for small area.
Even if consultant agree, we will not agree.
We will not
Yeah,
let them agree in that.
You tell them you do it at your own risk.
Why? For 2 square meter, you want to put such a huge effort?
No, you tell them if you do that, you do it at your own risk.
Yeah.
That's a big risk to do. If you do it, you're still gonna have noise, and that noise is gonna even cause vibration. It's best for you that to go for the whole space.
If possible, just extend the area to corridor also.
Oh, yeah.
Yes. Yes,
No, it's
that's
a
true.
solution. See, I'm not saying we need to. We need to give a solution.
Proper solution.
Proper solution.
Don't
Not-
give half solution. By
See,
this
I think-
equipment, half the equipment, don't give all those ideas.
You cannot compromise on quality.
See, I will not name. The company installed floating floor, and then they had a rework after 45 years. So they did the entire area, the entire system was doing the same efficiently working. What it was installed around 45 years back.
That is the quality of.
That is the quality of work.
Yes.
So it needs to extend, it is extended. Isn't it?
One more question, sir.
Yes.
Even this can be used with the wall.
It can be used, yes. It can be used.
Any-
However, normally you don't use it in the wall because
Better material. than-
there are other materials. This material is best underlaid horizontally. There are materials that can be used in the walls, and yani, imagine your workers trying to roll this up a wall and trying to glue it on the wall, and this rolls back on them. It's not practical. It's practical to do it horizontally. If you do that with the gun, the stapler on the wall, you can do that. I don't know if the performance is going to be compromised. You have to check with the supplier. I didn't see if it is installed on
Cost per
vertical.
square meter for the other material is much cheaper than this if you want to do it for a wall.
So we have a metal for the wall also?
Here it required to handle the weight. When it comes to walls, it doesn't require to handle any weight. So lighter density material, 40 kg per meter cube density, fiberglass, foam, lot of other best material are there with 1/4 of this price per
Yes.
square meter.
Absolutely.
If you want to cover 40,000 square meter, the underlay will be very, very expensive. There are other material, we will teach you lot of other material, you will be excited to see how
Yes.
acoustic material is going to work.
It's going to be a totally university for us. In times to come, we are entering with very, 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 very basic, products which require very minimum knowledge. But if you get into the detail, it is endless. You are going to retire and probably, I don't know, maybe few generations will keep working on it.
CP606 we are entering right now. The underlay is just like CP606. You have not even touched MEP penetrations, nothing. The moment you enter into MEP penetrations, you will find hundreds of other solutions. Why we are entering only underlay? Just to have huge volume with less product range. Once you have it, you need to hire probably 2-3 architects to handle our volume of business.
And when
Of
tomorrow's
course.
review, I am going to take maybe 45 minutes, 1 hour, I explain in more detail. What we are going to do.
So you can see here with the 3 layers, it's gonna give you a little bit additional performance. Maybe in the future we can put in the catalog the vibration isolation performance in addition to STC and
In fact,
IIC.
we are changing all our catalogs. As after our visit,
Anybody is minuting this point?
we are already changing our catalogs. All the new catalogs are going to come wherein which all the material is going to be specified with all detailed specs and
Yes.
technical data is going to be there. So we are changing it. We are just doing the background work now.
And providing that material to the consultant is gonna be the biggest help for you. When you put all this information in the specs, again, that is your trick. You put all the specs, nobody can outbid you.
2 different type of catalogs, one to give it to the consultant, one to give it to the customer. Customer catalog will be very simple and consultant catalog will be very, very detailed without technical information. So you don't have to every time bother for making a technical submittal. You give this and tell him everything is in this only, just read it.
Exactly. You can do that.
That will have all graphs, reports, everything in that. So consultant will not have any questions to ask. All permutations, combinations, systems, approvals, everything. That's all.
These are another system with FF06 and FF10, and it shows you the IIC and STC rating. Here you have 60 mm screed and 150 mm concrete for both, and it will show you the performance in STC and IIC.
So we can choose the material as per the project requirement.
Exactly.
Correct.
Suppose if less STC is required, so we can go for this.
Exactly.
You got it.
Also, as I understand that vibration performance requirements gonna be there in the catalog, so you can use that as well, specifically for machine rooms. So when you're dealing with mechanical engineers, that's gonna help you. Here are different, again, all these are different sections, and here we have plywood on top of the RNS mat, and here you have double layers of RNS mat and 2 times 12 mm plywood on top, so that's normal plywood, and you have a 150 mm concrete on at the bottom, so there is no concrete casting on top, and still look at the performance, 59 and IIC 56, which is quite good with cheap material. Here are 2 layers of mat and 2 times 12 mm plywood and 9 mm maybe top finish plywood if you like. So that would be maybe the pre-engineered parquet that has a look of parquet but only plywood. So you can have that, and it has very good performance as well. Yes.
So there is a code FF50. Is it a code or something?
That is the brand.
Our name.
Your name. It's here.
50 is 50 mm.
50 floating floor 50 mm.
Yes, these are
50 mm.
okay.
Identifiers.
Yeah.
Names.
Yes.
We need to study our material in detail and catalogs.
Yeah, it's your job as a salesperson. You will have to do it. I'm not gonna do your exercise for you.
Maybe STC and IIC. Those two, how the question will be like that. Like
Yes.
you have this much STC and IIC requirement, which you are going to propose. You have to choose the best design among them and give it to the customer.
They will ask you, see, as per our catalog, they will clearly ask you, this is what I want. Then you said, sir, you want this? I have more variants. What exactly you are looking out for? What is the value you are looking out for? Based on that value, you are tuck. Okay, this is the solution. That's what you need to say.
All right.
Yes, sir.
So the rest is just examples again. So this is again another example. So you have cross laminate timber. You don't see this construction much in the Gulf, but now it is used in many places in US and Europe. CLT, cross laminate timber. So they use the wood for the main structure of the building. Even they can go up to 12 floors, 14 floors, just with wood.
Use the weight?
Sorry?
Or to improve the acoustics value?
No acoustic value for that, because this is just the beams and columns made of the CLT. They two advantages. The first advantage, as you said, is weight. The second advantage is that these are pre-engineered, pre-manufactured. So they bring them to site and they put them. So you can have 12-floor structure in 1 month.
Construction time.
Very fast. Construction time, and when you cut the time, you cut the cost. And now with the new technology of CLT, it is also fire rated. So that structure, these structures are fire rated. They can get fire rating in US and Europe. Here, not sure yet if the officials will agree in the Gulf. But
Because of weather, they are using wood there. Maybe that is something.
whether, no, if you want, it's because of the supply. But also there is another advantage to wood, which is carbon sequestration. So for green building purposes, certification, CLT is better than concrete. Okay? There are many advantages to that. So carbon sequestration, that means you keep that carbon in the building and then don't let it go up into the atmosphere. So that timber, wood is there, you just put it through a little bit of manufacturing and then it's off to site. The manufacturing process will emit CO2 much less than the concrete manufacturing process. So these are advantages of CLT. There are many types. So there is CLT, GLT, glulam, but CLT is the most strong type because it's cross laminated, so it's laminated but in different directions, and the beam can go very long, like 12 meters, so you can have big spans with it, which is good for the construction. So as under layer of the construction, it can be CLT, and then you have the mat, and then you have the topping either with the, so here you have a screed, and on top of the screed you have vinyl tiles. The rating is 53 and 51. This is also CLT with the double layer of mat and the screed on top, and the rating 59 and 54.
So this STC and IIC will be provided by the client or
No.
By the manufacturer.
No.
if we are going on a
No.
site?
No.
Or it
The
will be
STC is for that exact system.
project specification?
Project specs, as I said, it will be something like that. Sorry, I went down.
Will be
Something like that. So I have a bedroom, STC of the slab should be 52. If you give them anything above 52, you're done.
It will be acceptable.
Yes. So, for example, let's say we have this system here. This is STC 70, it's too high. Let's go for something lower. This one is 59. So if you suggest this, it will be enough. Okay? So
6 mm.
yes.
6 mm, no? Floating floor 6 mm we have to provide.
So this is RNS mat FF06. You have 6 mm, 60 mm of screed on top and 150 mm concrete. If they tell you my concrete is 240 mm, tell them it's fine. Okay, you're better. That's gonna give you a minimum of 59, and you can do better with your thick slab. That's it. All right.
But we need to know the slab.
Remember, it's a mass law. The more mass you have, the better. STC and IIC. All right.
Thickness of the slab.
No, see, when they are going for such a thick floorings, the loadings will be more, no? Based on that only they will develop the thickness in the construction. On those parts, the acoustic parts
Not
also
much.
to be increased.
Not much. I can assure you that a 100 mm of screed is not going to increase the load by much.
Your 2 PSI per inch is already mentioned there.
Yes. It's not much. Structurally, it's not going to be by much. But still you have other examples. So you can see here in this example, you have only plywood on top, and still you achieve 56 STC. So you have the 150 mm concrete slab, you have the underlayment and 2 layers of plywood planks. You achieve 56 STC and 56 IIC. With an additional 9 mm layer of subfloor, or 17 mm here you have, you're achieving 58 STC and 59 IIC. All right? If the client tells you, I don't know what to achieve, show them that example, and they can extrapolate. Okay?
This is your main, okay? So you need to concentrate on this.
How about hospital? The same hospital.
More or less is the same. However, when it is a hospital, you would have an acoustic consultant School and hospital, normally you have an acoustic consultant, and they're gonna give you better figures than
So
this.
the figures are same or different?
It's a bit different.
So machine room.
Machine room also, you would have the requirement of engineering. You will have the rating of the noise coming from that machine, how many dBs. You will have the requirement for the vibration isolators and the underlayment. All these requirements are going to be given to you by your
This
engineer.
is just a general.
Yeah, because-
As a specific we can get.
Yeah.
Exactly.
For the machine load, you will ask for the equipment, what the equipment will manufacture. What is the
Exactly.
load, what is the capacity, you get it. And with every equipment, it is already specified.
So they are going to provide it?
Yes, we
Yeah,
need to
sure.
ask it, yeah.
And then
If they don't, then
If
tell
they
them.
don't, then you have to
If
ask
they
them.
need a proper solution, they have to provide.
They
Yes.
have to provide.
They have to provide. You cannot give them a solution without knowing what is your data. You need the data to give a solution.
But I can understand your feeling. Most of the contractors will not be ready with those data.
No, don't think like
Not the
all
contract.
iconic project has got an acoustic consultant.
Consultant.
Much before the project is awarded, there is an acoustic consultant who is being paid huge amount of money. He already then done the total detail engineering.
See,
Yes, normally
for
this is it.
hospitals, there are only specific consultants who will write specification for hospital, no one else. Even Econ is not doing, PNT is not doing, you know, SNC level is not doing, you know. There are very, very specific people who are doing it. Isn't it?
All iconic projects like museums, very big five-star hotels and all, there is a specific acoustic logic, lot of people are there, very, very big,
Very,
big
very
acoustic
specific.
consultants.
Correct, sir, but we are dealing with the contractors, no? So the contractors will not be having the data.
No,
They
no, no,
sit
no,
in-
they will have it. They will have it. So our consultant will
You
give
mean
them.
to say that is the best part of acoustics?
Consultant will provide.
Highly specified and highly technical.
Consultant, without consultation, they will not go anywhere. They have to give it.
Because if something goes wrong now, it will be millions.
Yeah.
One Crown Plaza is the best example. How one small mistake in acoustics to save some money, how they got screwed with the five-star hotel.
They will demolish the entire building.
Okay, so here in this is the RNS MAT F70 and F70 LDM. You can see the section here, an example. I just want to, another example in your catalog. I just want to point you out to these figures. There is a delta in front of the IIC, and here this delta is actually giving the difference in increase of IIC that this underlayment is going to achieve. So no matter what kind of system, the delta IIC, it means it's going to improve it by 35. That's it. So if your slab is 50, IIC 50, adding your underlayment in principle is going to be 85, like that. Okay? Here, this is an example showing you your section, and it's gonna give you these results. This is the RNS MAT F70.
Can you repeat the data point again, please?
It's the difference in IIC that your underlayment is giving. Again, you have to be careful when dealing with delta difference, because that's a logarithmic thing, so it depends on what kind of frequency, and the actual IIC might not be 35, in fact, might be a bit less, might be a bit more, it depends.
What is the maximum average plus and minus?
Depends on the material. There's a lot of dependence, so it's very hard to predict like this with one word. However, you can use that for marketing. So you can say if my IIC is 40 or 30, you can make it 65, which is written here. So that slab without your mat is gonna be 30, 35, and if you add the slab, it's gonna be, or 30, and if you add the underlayment to the slab, it's gonna be 65. That is what it means. The delta IIC as per ASTM E2179. So there is a special way to measure it, the procedure to measure it. But again, I must caution you not to give it as a hard engineering number. However, it's an estimation number. It can give you a good estimation. Okay?
So in case some customers comes with a delta value, how we can compromise it?
What do you mean?
Some customers coming with this point, what is the delta value of the product? Yes, it is mentioned like 65 in our document. If they are asking us to brief, on which way we can brief them?
This is how you can brief. You can say that my system is improving the performance. So you have here a slab of 175 mm cross laminate. Without this system, it's gonna be only even less, 30. You have added the 35 to become 65. So you can say that without that, the cross laminate by itself is gonna be only 30. Okay?
And if we add, then it will become 65.
Exactly.
Understand?
That is what is meant. Noise and vibration control. You can see here you have a basketball, so that is one of the uses. You have office or public space down, and you have a basketball on top, and the impact of the ball and the jumping of the players will all cause a problem. So using something like this high duty or heavy duty mat FF70 or FF70 LDM will give you, are recommended for such application. This is an example for hardwood court flooring. So you have a court, basketball court, volleyball court, whatever, and then you have the RNS FAS, which is the, I think, the glue or the adhesive, and then you have under that plywood, and then the RNS mat FF70. That's giving STC of 61 and IIC of 66. Remember, that's for a slab of 15 centimeter or 150 mm only. If you have a 240 mm, that's gonna be different, higher. Okay, that's it. Any questions?